You know, it was not. I double checked that before stream, and then I didn't actually hit the fucking button to turn it on. Hi, everybody. Hello. How are you today? Thank you for checking. Classic. Yep, I had to figure out why this is going on. So if I don't do the print there, we still get the seg fault. Okay. Well, where fprintf file state render diagnostics to file. Render target is null. Yes. So you can't print null. So if there are no diagnostics, right, because we were testing diagnostics, so now that we've removed the diagnostics, I don't know why it's so bad. All of a sudden, my room is really fucking hot. That's bad. Okay, so if render target, why are we at the beginning of the line? Okay, now that removes the seg fault. Okay, now we can start thinking about a parser. I need to go back to wherever the hell we are printing here. So when we're adding a source file, we're getting all of the tokens from it right here. Then after that, we've got our printing of the tokens, and then we've got cleanup of the stuff we don't need anymore. Such an inefficient use of space. Yeah, with everything at the bottom. I don't watch live streams that much on YouTube, so I'm thinking, what, it's got the big player at the top and then just chat and then a bunch of empty space at the bottom, or like... So we definitely want to free tokens when we're done. Returning the source ID, we're going to want to be able to query the source text, which we can do, so that's fine. Okay, so when removing that shouldn't change anything other than it's not going to print the tokens anymore. So now let's go try to write a parser. I start writing a parser and I go whole hog. We're going to start parsing declarations first, which I don't think is a good idea here. So what we are going to do is probably start just parsing. We could parse this print statement, and that wouldn't be bad. But that gets us into like function calls. We could start being a calculator and print, like do 1 times 2 plus 3 and go over operator precedence and parse that as our start. That's still complicated because operator precedence. So we could just start with 1 and work our way up from 1. Then go to operator precedence, maybe do foo and call and stuff. But I want to do the opposite of what I normally do, basically, and we'll get to functions and variable declarations last, as far as parsing goes. But if you guys want to see anything in particular in the parser, we can work our way up to that, if you just let me know. Give me a second to put my jacket away, so it's not falling down my ass. Nobody wants an ass jacket. So in order to get there, we have hbk parse, which if in def hbk parse h define parse h and if. There's our parser. So in lex h, we're just including the API and the public header, which should be fine for us as well. We might not even need standard int, but we'll see. We need parse.c, hbk parse c, to include hbk parse. Here we're going to have a parser, type def struct hbk parser. Type def, there it is, okay. In our parser, I'm going to give it a dummy right now so we can start thinking about what's going on. The thing we want in our internal API for everything to have access to is the ability to parse a whole ass file. So we can start with, make it void for now because we don't have a return type. HBK parse file. We can make it the same naming convention as Lex. So Lex said read tokens. Doesn't say from file. We definitely didn't use the word file anyway because we're calling them sources, because you can get source from places other than files. So we could just call it HBK parse. Read tokens and then parse. Could just be HBK Lex and HBK parse, honestly. So maybe we refactor that. So HBK parse is going to have probably the exact same signature as HBK Lex, taking in a state and a source ID. Then here's the thing. All the work that we just did in Hibiku here to get the tokens, we can probably skimp out on and just not do, or we add an internal API call to get the tokens. Either way, we only want to get them once. So Hibiku parse. Let's move parse here since it's the thing we're working on. This is our parser entry point. We need some way to get a vector of our token for the parser. Make it null by now, by default. HBK vector is undefined. But HBK parse includes Hibiku, which defines the vector. So HBK token is undefined. Oh. Yeah, because we need to include Lex after this. You know, since we called the header file HBK Lex, just like we called this one, maybe we do go refactor the Lexer real quick, just because I'm in the mood. So if we look at HBK Lex, it has token kind to string and read tokens. Let's just say HBK Lex instead is the new internal API name. Cool. So we need an internal way to get, and this being called API I don't like, by the way, since we're on the topic of renaming things. I like this to be HBK internal, probably, because it's not the public API. But then there's a couple of places that should have been updated. HBK internal. So lex.h needs to say internal, which really means that lex.c does not need to say it. Then HBK hash map we are not going to get around to for a while, same with IR. Just did lex.c and lex.h. Memory, we don't have anything for yet. We put it in the internal, I think, so delete that. Parse, we just decided needs internal. Then vector is still an implementation. It's going to get internal. Then HBKVM doesn't exist yet in Hibiku.c. Hibiku.c. HBK internal. Yeah, internal. Okay. Does that still build? HBK memory.h in internal. That's it. So internal was including memory, but there was nothing in memory.h, right? Because we moved everything out of memory.h into here. Gives us our pool. Right, so then hibiku.h has our vector. There's internal, hibiku.c, hibiku.parse. Okay, so now we can replace this dummy field with all the tokens that we're going to be reading through. The current index into the tokens that we're reading. Then. We need some parser, primitive, not primitives, but like, you know, functions. This first, let's construct it before we even get there. So HBK parser is tokens equals tokens We need to get those tokens from somewhere. So this is why I wanted the public API or the internal API to update, because we want HBK state. If I say get source name, source text, we're going to say get source tokens for now. State source ID. Which could just, again, become HBK Lex, but we kind of want to cache this. Not because, like, oh man, we're going to do it a whole bunch of times, but, I mean, honestly, we might, depending on what we do in the future with Hibiku, but it's not a huge deal. I just kind of want it to not rely on parsing tokens or lexing tokens itself. So in HBK internal.h, that's got string interning. That's got. Okay, so I guess we could put getting tokens in the public API. They're in the public. No, Lex is private. Ah. So since Lex is private, we probably want to put it in here. Or just let the parser do it itself, I guess. For right now, HBK Lex can be responsible for caching, I think. So HBK parse can just say HBK Lex. Then that gets us the tokens. So then in hibiku.c, one of the things we're doing here is lexing. We're going to include that in our big if0 block, which also means we're going to move the 3 in there, and our tokens don't need to go there. So now let's change this to something else, like, I'll put it down here just so it makes more sense that it's after whatever we just did. HBK parse needs to come from parse. So I don't think I need Lex anymore, but I do need HBK parse from state source ID, and this is going to return to us the tree. Right now it doesn't return anything, but that is fine. So in HBK parse, this is where we're going to define a syntax tree. And I want to keep the syntax tree as simple as possible. It is probably still going to be a tagged union because we're in C. So let's say type def HBK. I could just call it HBK node. Syntax node. HBK node makes enough sense, but I think we're just going to do that. So enum node kind. You need that. This, we're going to do the same kind of thing we did in the Lexer. We should probably make that update I was talking about to the Lexer enum as well. So HBK node, did we call it invalid? Probably. HBK Lex has this X and Y. But really, we just want it to be I should have written down what I wanted to do. We do want this to be just an X without a Y here. So we're going to want token KW kinds to get W like that. So then we can just say token kinds is going to call all of the, hold on, before I think too hard about this, we need this to go here. I'm going to just get that in my, okay, so then TK needs to also include all of our keyword kinds. In order to do that, well, we can put KW kinds here, but then KW kinds requires KW. So what we really want to do is take KW here all the way down, make it X, and then make TK X. And this is going to take in X, and then our X macro just needs to be variadic, basically. So this whole KW thing here is our TK. We can keep TK, just pass in TK. It's variadic, so it's great. Then in the lexer here, keyword and token are still the same, but they still need to use variadic. What the heck? There we go. That. And then here, we only need KW. We can say KW of KW. Cool. Then I believe that still gets us almost there. Okay, HBK internal.c never got updated. Let's say internal. Okay. So now we are calling the parse function, which is still lexing tokens, right here, and we're building a parser. We don't have anything to return just yet, but that's fine. So let's go into HBK parse, and I'm probably going to go ahead and only HBK module file root. I call it a module in Laye. Does the language spec exist for Hibiku yet? No, it does not. I haven't really designed much of the language. We're kind of doing that on the spot. I have high-level idea, and I'm allowing that to change over time. HBK module file syntax root. Naming things is hard because I don't 100% know what semantics I want yet. So we could just call it module, but we could call it root. HBK root, syntax root. If I used the word syntax, then every name makes more sense. Tree, we'll just call it the syntax tree. Boom, easy, see? So then this is a node. I should probably just call it HBK syntax node to be consistent. So we have a syntax tree. We're going to return a pointer to a syntax tree, probably. Doesn't have to be a pointer. We could go ahead and make it a value, because the value of the tree is not what's important. It's the children that are important, and those will be reference. If I do this, it has to go in a pool somewhere, or we have to be responsible for it. So if we do that, then our state would need to use the MISC pool. We'd have to add an allocator for it. So we can probably just say that HBK state can have a temp allocator. So this could be temp pool. MISC pool works. So if I go into internal.h, we have HBK pool stuff, HBK interning strings. We can probably say void star HBK state alloc, HBK state state. Oh, we could ask the state to give us a pool. That might be too much. So, right. What I was gonna say is maybe we don't do that. Maybe... okay, what might be funny here, but also not terribly stupid. Where did I put my parse h? There it is. Let's make this a pointer, and let's say struct syntax tree. Oh, let me get rid of my error though, so I can see what the hell's going on again. This has to return the same thing. So in parse, we can grab our tree, and it can just have a pool of its own, which I think has to be a pointer, and we can just call this allocator pool. Data pool. Data. I don't know. In the pool here, we can just make our own pool, use our own allocator, do everything syntax related at this point to just our own pool. So then whenever we destroy a syntax tree, we just destroy its pool. And we can allocate the syntax tree in its own pool. Easy enough. That sounds doable. So then I can just have a fancy old void HBK syntax tree destroy HBK syntax tree pointer tree, and then easy peasy. If the context state wants to deal with it, they just call this function. So if tree is equal to null, return HBK pool destroy tree pool, which frees all the memory associated with everything. So for now, that's everything. That's it. That's all we have to do. So let's go ahead and HBK syntax tree create, which will just be local to this file. So we want HBK state, because we can hijack its own allocators if we ever do that. But for right now, it might just store itself in the state. And that's fine. Basically, we want a HBK pool, tree pool is pool create. We've said pool create gets its own default block size. Yep, that's fine. Then we'll still have to implement assert at some point, and I don't think that's in our to-dos. Yeah. We're doing parsing right now, so we'll come back and add new to-do specific to parsing in a second. What does this have as an error? HBK pool. Okay, so there's something. Like, close that and go back into it. Is it still mad? No. Okay. So probably the same thing here. Cool. Parse now needs what? Here. Plus a message. Then we want HBK syntax tree. Tree is pool allocate. Tree pool, size of tree, assert tree not equal to null, and tree pool is tree pool, return tree, not true tree, not true tree. This needs a syntax tree as its result, and then we can say that our result here, tree create in the state. We don't need the state just yet. We probably never will, but I'm doing it just in case. You know what? Let's not be wasteful. We don't need that shit. Syntax tree create. So then we can return the tree. The parser should potentially know what tree it's parsing into, but I don't think it needs that, since we don't have any state within the tree that isn't just what we're parsing currently, so that's fine. What the tree needs, though, bring parser back over here. The tree needs more than a pool. It needs HBK vector of HBK node, syntax node pointers for syntax nodes. Could call them expression statements, I don't know yet. Syntax nodes. And on that node, syntax node, I'll just call it syntax. So really, we don't need a node kind. We just call it HBK syntax kind. We don't need these to be explicitly called nodes either. We could just call them HBK syntax. And that's fine. So now we have a tree. This syntax tree might want to be associated with a source ID just for shits and giggles. So like, source ID, source ID. Even though all of the syntax nodes will have it in their location information, it shouldn't matter that much to put it there. So parse tokens is tokens. Tree source ID is source ID. Parser has tokens. Okay, so now let's do a HBK token. We could get the entire current token for HBK parser, current token, HBK parser. For convention, we're going to call it P. Then HBK assert that P not equal to null, valid parser pointer, the pointer for parser. The pointer specifically designed to store the parser pointer. Tokens, we need to say that what range do we want? I think we're just going to say if P current index is less than 0, which it shouldn't ever be, but that's fine, or it's greater than or equal to vector count P tokens, then just return basically EOF. So Hibiku token, HBK token, god damn it. Kind, do I have a token EOF? I don't. We should probably have an explicit EOF token. If we don't already, which I think we don't have. I don't have it. So EOF can just be probably 1. And then if we go into HBK Lex C, we just want to add a case in here for EOF. And then, do we have any cases down here where the Lexer returns EOF? We're not like including an EOF token in the token array here. If it's EOF, it basically just stops. So if we read token, we probably also want to HBK assert not EOF. L cannot flex from EOF. And at this point, we're assuming that the next character is valid because we've also already skipped white space before and after. We should never be at EOF, so the Lexer should never return EOF. But we want to have like an explicit flag for the parser, which is probably just going to be EOF. We don't want to return invalid, probably. We could, I guess, but end of file sounds like it's better for internal semantic stuff. Okay, so in order to get the EOF token to have a valid location, it's going to need location create from P source ID. We don't have the source ID. That's what we need first, though, right? Is the source ID. Hello, location create. Give me your information, please. HBK location. What I'm calling it. So source ID first. He doesn't have a source ID, but it will because we want to get location information and everything the same. Offset will need to be the source text length, which we could keep looking up every time we call this, but we might want to just cache source text and say count, and length can be 0. So in the parser, we need HBK source ID, and HBK stream view source text. Okay, I really need to get a duster. Dust keeps falling off my ceiling fan and right onto my desk, and I keep thinking it's like giant ass bugs come to kill me from space or something. Okay, so source text.count works. So then in the parser, we need dot source ID and dot source text. We need to get the source text. String view source text is going to be get source text state source ID, which should return a string view if we're smart. It does. Cool. So now we can check return p tokens sub tokens sub I, not I, sub p current index, like that. Cool. So now shortcut to getting an always valid token without having to do bounds checking. Then we can write a bunch of things in terms of that, such as bool hbk parser at, which is going to be hbk parser, and hbk token kind. That's just going to return parser current token e dot kind is equal to kind. Then we can have bool hbk parser peak. I usually in Laia call this peak at, because I could also have peak token to get the actual token value of what we're peaking. I don't actually know. I don't think that Hibiku is going to care much about the next token. So for right now, we're going to say peaking doesn't exist. So parser at, and then void hbk parser next advance. I usually call it advance, but we could call it next token. We'll just call it advance. hbk parser peak. And since this doesn't depend on anything else, we're going to assert that it's null. P current index plus plus. Simple as. Then, so we can advance, we can check. We can get the whole ass token if we want. Another thing I'm probably going to shortcut so we don't have to write extra code is location. I probably won't call this current token then. The parser token and the parser location. Right? Location, which is going to return hbk location. Then we don't really need a way at this. We might want a version of at that also eats it called consume. So if hbk parser at p, then return true after parser advance, which doesn't exist yet, so this will have to go up here. And really, it has no dependency, so it can move up all the way at the top. So if hbk parser at kind, advance return true, return false. So go to the next token. What is the current token? What is the current token's location? What is the current token? Is it this? And is it this? And if so, advance. Little shortcuts that are very useful. So I think we can start parsing something. Something that we can start parsing will be, I guess, like I said, primary expressions or leaf expressions. So we can start with things like 1, 2, 3. I'll even put them on separate lines so it's easy to see. But we could say 1, 2, hello, and true. And those can be our 4 leaf tests. So in here, what that means to me, let's go ahead and create a void, no, not void, hbk syntax pointer, hbk parse primary. We're going to call it primary like I do in everything else. HBK parser. And I don't think we need anything else. We're going to leave it in a forward declaration here because recursion means we might be jumping around all over the place between different functions. So any of my parser functions are just going to get forward declared right here. And for clarity, I think I'm going to put them all the way the fuck at the top. So parse primary, we want to do a couple things. We're always going to throw down a invalid parser pointer for these entry points. I guess we really don't have to, but it helps sometimes. Sometimes things break. So we are going to, could just do a bunch of ifs, but I could also do a switch on a kind. So like switch parser current, parser token, the kind default do nothing except for report an error and advance, I guess. So parser advance, we'll want HBK location, location. It's just parser location p. We want to HBK diagnostic create format probably. We're going to say p doesn't have state. We do want to push state into p. HBK state. So then state. So create format. Does it take the state first? It does. It does everything else first, of course. So the state, the kind would be diag error. The location is location, which I can actually inline to ease copy pasta errors in the future. And the message. The message that we care about here is, like, we expected an expression, but we got something that wasn't an expression. Expected, unexpected token, an expression. I don't want to use like fancy words. Writing good error messages, always hard. So expected an expression, but got a token kind, which we have kind of the ability to get. Problem, technically problem, it's the internal name, not the visual part of the token. So we either want a human readable name or to just not care. I think we'll do that in a to-do. For now, we're going to say mod s and just add token kind to C-string of HBK parser token p kind, right? But we're going to throw here to do turn token kinds into more human readable strings, not just the internal representation of their enum, but like, okay. That can go verbatim into the readme, not the readme, the to-do me. Where's my to-do me? If you don't understand what that meant, what I just said there, do feel free to ask. We then need to return a, let's just keep hold of the token here. HBK token is this. Copy token paste, right? Because then we can turn this into an invalid node pretty easily. So now that we've hit here, we need to be able to return things. In order to return things, we need to have something to return. So it's time to build our syntax. I know I'm just chugging away at this, but I will reiterate, I am down to pause, answer questions, do whatever the hell. Sidetrack me, I don't care. We need an HBK node or syntax kind for our kind to do stuff in our union. this is something I expect people will probably have questions about. If you've never seen unions in C, or you don't know what a tagged union is, or right, at the very least, I can come over here and say C tagged union. We can add a Wikipedia entry, because Wikipedia, of course, will never die. If you don't know what tagged unions are. Let me also make this slightly bigger. That's the zoom the whole screen button. That's the, there we go. That should be better for you guys. Cool. Cool indeed. Then, okay, so we want like an invalid token. So we could just say, doesn't even need to be a struct. It could just be the HBK token, invalid token. Yeah, that would make sense. Okay. So, well, there's lots of things that could be invalid, and we want some way to represent them. So maybe we say invalid and then HBK token, just in case we want other ways to represent invalid data. I don't know that we'll have significantly complicated invalid data structures for a while, if ever, but slightly forward thinking to do it this way instead. So now we can do an allocator for our syntax nodes. HBK syntax pointer HBK syntax create needs to be created in a tree because we've decided that's where the pool lives. So that's not ideal. Maybe we don't put the pool in the syntax tree, right? Because we don't have access to the tree, and I don't really want the parser to care about the tree that it's in. So maybe we create this in... Well, I don't really want it to be in state scope either. So maybe tree is correct? Well, this is the internal thing, so maybe we also just don't care, period, and then we can put it in here. And then if we put it in here, right, if we said... Well, we've got tree destroy here, so immediately after tree destroy can be syntax create. If we do create things in parser context, HBK parser, right, then the parser needs to know about the tree. So dot tree equals tree. We're going to make sure that the parser knows about the tree. HBK tree. Then we want to say HBK pool pointer. Pool is p tree pool. So HBK assert p not equal to null, I guess. No, parser pointer tree and pool. Valid pool. So then pool alloc for HBK syntax pointer syntax pool size of syntax, return that syntax. Okay, so then what we want to do is be able to set the kind, and this is also the kind of thing that we want to forward declare, so I'm going to do that up here as well. So we have added the kind. We also really want it to take the location. kind and location. So syntax, kind is kind, location is location. So we need to go back into the syntax to make sure it's got HBK, okay. HBK, location, location. So every syntax node has a kind and location associated with it. And there are other things that we can do. I forgot I had a snack next to me. They're drying out. I brought chocolate cake to snack on during the stream, and I've left it there for an hour, so it's all dry now. It's very sad. Still tastes like chocolate, but my cold is way better. Okay, parser. Now we're just going to say return, not invalid, create. For P, created in the parser. The kind is node. We don't have like a node invalid. We have a syntax, but we don't have a syntax. We do have a syntax invalid. Beautiful. Token location. And we don't really have, we want to say HBK node, HBK syntax. I call my Laie one Laie node. So I'm just going to be used to typing that, even though. Anyway, invalid equals return invalid. So then invalid, invalid token is token. Easy as that. All right. So now we can parse real stuff, like token int. We have an integer literal. That'll be nice and easy. It'll be very similar here where we want to create a syntax integer literal. And we'll want our, like, I don't know, literal dot int value or like int literal value or I don't know to reflect something here. What I'm thinking in my head is not actually important. Yeah, that's probably fine, because we can say integer value is token integer value like that. Literal integer value is going to be an int64t. This is also going to have things like double for a float value. It's going to have bool for a bool value. It's going to have a HBK string view for a string value. Characters are integers if we do characters. I think we're parsing character literal, so we probably are doing characters. Then we need the syntax nodes for things. So let's go ahead and set back up our define HBK syntax kinds. And we'll steal the X macro from there. And we'll say define SN of N to be HBK underscore syntax underscore N, comma, undef SN, okay, HBK syntax kinds. There's more dust floating around my room. Get off my monitor. It's on my keyboard. God damn it. Okay. So then we want to add our first one, x of integer literal. While we're at it, we'll add a bunch of other things. So we want string literal, float literal, bool literal. We would put string at the end of the thing. So that gets us literals. Let's do You know what, fuck it. We're not going to think too far ahead. We're going to do the ones that we're doing, and we'll add the rest later. Format to get those lined up. Go back to the parser. That should exist, but it does not. Oh, because I didn't pass in fucking SN. Like a Dumbo. Like a Dumbo. So literal integer value, whatever, cool. So then we just skip it. Do all the exact same junk for the other things. So we have float literal exists, I believe. Does not. Integer, string, and character. Okay, so we never actually did floats, even at the token level. So we have string and character. Let's do character first, which will be an integer literal. The integer value will be the integer value. It's fine. We might have some additional flags saying it's a character literal instead of an integer literal, actually. That'll be a semantic distinction if we care. If we do care, we'll just come change it. String literal will be a string of literal string value or string value. They should both already be string views. They are. Then do true and false. True. False. Bool value is token kind is equal to token true. This would be a bool literal. So that gets us the four things. Well, we haven't done identifiers yet. That gets us 3 of the 4 things in our example program. So let's move foo. Well, foo can be our invalid test. We haven't done it yet, so sure. Let's see if that generates an error. And that's good. So let's set up our parsing loop. While not, we need an EOF then. The EOF check can be while not parser at parser token EOF. We might introduce an end of file check later, but this is fine for now. HBK syntax, parsed syntax is going to be parse primary of parser. Assert that parsed syntax is not equal to null. All parser routines must parse, must return some a valid number. How about that? Okay, then we need to add it to the tree. So we can say hbk vector push tree syntax nodes parse syntax and continue. Another thing we can assert is we can say int64t last token, last parser index could be parser index. So we assert that it's not null, and hbk assert that last parser index is less than parser current index. All parser routines must advance the token index by at least 1. So some little sanity checks to make sure we're implementing parser routines as correctly as we can. Then we return the tree. And before we get on to debug printing the tree, we can at least come back down here and see. I want to be like here, right? Yeah. HBK tree is this. HBK assert tree not equal to null. Make sure we're getting valid data. Parser did not return a tree. So we should see one diagnostic, and if we do, then we're good to go. And we can start doing debug printing and stuff. Well, wrong kind of diagnostic. So in HBK parse, we have a raw, flat, flat, raw, flat, assert, which should be an HBK assert, first of all. Second of all, we have HBK token in parse.h. Parse.h should include lex.h, and lex.h has HBK token, so parse.h doesn't include lex.h. Well, that makes sense. I mean, it should. It doesn't make sense that it doesn't, but it makes sense with the problems. So then we don't have to include it at the top here, it's just part of it. Process expected an expression but got identifier. And that's the only error we got, and it's reported 2-3. This is not line 2. This is 0, 1, 2 bytes in, and it's 3 bytes long. So if we go into Hibiku here, and we can look right here, 2, that's the number of bytes in, and foo is 3 bytes long. So goes to 5. 5 minus 3 is 2. 3 selected. So it's reporting over the correct range, and it's telling us that an identifier was not expected because we haven't implemented identifier parsing. Only number, string, and true or false, which also means that our Boolean is still being recognized as a keyword properly. We hit the end of file, and we should be good to go. So now we can either continue parsing or start implementing debug printing of the tree. I probably want to debug print our tree as soon as possible so that we can see what we're working with as best we can. So my vote, if nobody tells me otherwise, is that I'm going to implement a debug print of the tree, which will be an internal thing that anybody can call at any time. Void HBK syntax tree print to string. Just grab the syntax tree here and HBK string out string, and probably bool use color. I think that is sufficient, and we'll stick it way the hell down here at the bottom and say debug printing stuff, just to get it visually out of the way of the parser. It has to do with the tree, but I'm not going to put it in a different file. It's fine. So this is our entry point to printing the thing. HBK assert tree not equal to null, invalid tree pointer, out string not equal to null, invalid string, string pointer, and that's fine. So then all the way up here, we can define some colors, like color tree can be red. We like red. Color for literals can be blue, cyan. Color for names can be like green. You know what? Normally I do trees that are red, but we've got this fancy purple and blue and green and shit going on. Let me see if I can't say that the tree should be blue like this. So this will just be straight up blue. Fancy color blue, like that. Names, though, are what we want to do blue, so I guess not. Maybe this means they'll be purple. We don't have purple, though. We have, like, magenta. So maybe I do regular-ass magenta and hope it's not bright as fuck. Because I don't have a dark magenta. I just have not bright magenta. There's no purple, unless I'm stupid. Could do bright blue. I'll stick with magenta. So then literals, like pen, are orange. We don't really have an orange, though, right? No, we have yellow and red. So I'll just say yellow for literals then. We'll tweak these later. Then we can do things like pointer can be gray. Gray is bright black. Then Position can be, this could be red. So we don't really have red going on in here, so red is fine. So the pointer is the pointer of the syntax node. The position is the byte position in the file, the thing that we're currently printing here. So we'll probably print like literally just this. The names can be blue, literals can be yellow. Tree is magenta. I guess these could be green instead of yellow to match these. Or I could do green for types later on, basically, because these two greens are going to be hard to replicate without doing like RGB colors, which I could do. I could turn these into RGB colors, probably eventually. I don't know how to do that. I know it's possible, so I can probably macro it away in the future. Okay. We'll make more of those later. We should just have straight up call, yeah. All right. Now I'm going to cheat a little bit and go grab some things from Laye lib. And we want the debug file, so Laye debug. Okay. So what we're looking for is somewhere down here. This. I'm going to steal print children because it handles these fancy printing characters for us. I'm also going to get this out of the way so I can reference it without pain. So this will be HBK syntax. Print children to string, probably. We can print children to our print context here. HBK syntax print context. Type def struct print context print context. So this is going to need some things. And then this dyn array here is an HBK vector. This Laye node is an HBK syntax. If I can spell HBK syntax correctly, then that print, we'll get to that in a second. Print context needs bool use color. Print context needs HBK string. We're calling it output. The indentation needs to be a string. Indents, like that. So then that's an HBK string. The next children k, instead of our count, it's HBK vector count. This color is last. I'll even do that like that. Do this. We have color tree, that's there. Stir expand is going to be HBK SV expand, but it's not a string view. It's a null terminated string, actually, so that's fine. This is just going to be raw indents, because there's nothing to expand, so this is that, plus the next leader. Right, so then I want to vector set count. Print context indents to the last indents count. So really what this is, I should just do this and say int64 last or old indents count. We can just steal this. We do want that because it's vector count of this. So then set count to old indents count. And then this sub old indents count is null. And I'll terminate the string again. We want to do that at the very end here. So indents, that's fine. Append format, the thing there, then set the count back and I'll terminate it again. Okay. Get the child, get the indentation, count, print the leader, which is going to be color tree, all the current indentations, the indentation for this node. Then, hold on. Oh, right, that's going into the indents, which is already stored here. Then we print with a new indent for its children. So append to indents. So I probably don't need this then to be, that can just be this. So then here, that's this. Here, that's this. Because we have print context as a pointer here, appending to it is fine. So string append format should be HBK string, or string append format like this. Append to the output first, then append to the indents. Then vector set count, and this, like that, should all still work. So then we need to define syntax print as void HBK syntax print from the print context, HBK syntax, I'll just call it node. So this can get implemented down here closer to where we're looking at it. And that's where we want to start doing stuff. Right. Right. So then we want to do a couple of things. First, let's verify that print context. That. This. Then Hibiku syntax node pointer. Cool. And we also want to set up the tree before I forget to do that. Quiet chat today. Tell me if I'm boring, okay? So we need HBK syntax print context. Yeah, I did call it syntax print. Print context is going to have indents is null by default. I'll make that explicit. Output is outstring. And use color is use color. Then for everything in the tree, we're just going to print it straight up. So for int64 ti equals 0, I is less than vector count of tree syntax nodes I plus plus. Well, that's good. int64t is that. HBK syntax print, I can type today, reference to print context, and three syntax nodes sub I. That should give us every node to print. We don't have to worry about printing children yet. I grabbed it just in case, but we're going to test this on things that don't have children. So one more thing to do, that is to append everything we want at the start of a node. So string append format to print context output. Which is going to have to be like that. We've decided the way we've done it. A little ugly, but it's fine. We need to print a lot of things. So we're going to get this all on the next line. We want first the color of the tree. Colored tree. We want a second. Why doesn't it like this? We don't have use color in scope. Bool use color is print context use color. So then the second thing we want is the thing that will be colored tree colored, which is the name, which we don't have yet, of the syntax node. So HBK syntax kind to C string of node kind. So we'll have to go implement this. We'll put it in the parser here. So const car pointer HBK syntax kind, and we'll do that in exactly the same way that we did the other one. So switch kind default doesn't really. What did we do default? We have a couple of things we could do for default. What did we do for default up here? We just didn't. We did. It's right there because it handled this. And we put the assert. That's right. So we can just assert unreachable, basically. Default HBK assert false. I have unreachable, actually. Fuck. HBK unreachable. There we go. If it's unreachable, I don't have to return null. So define SN of n to take this and say case syntax n and return n. Hit the right buttons, I think that's it. Undef SN, syntax kinds of SN, format. So now we have kind to string. Way the hell down here, where we just were, sorry to bounce around a whole bunch, we now have syntax kind to string. After that, we want, so in Laye, I have a, is compiler generated flag on all of my syntax nodes that I could put here. I'm not going to do that for right now. We might want to do that just for debug purposes in the future, but we're going to skip it for right now and go straight to the pointer, which will be, I think I called it color address, which is probably better here. So I want to do that, color address and color location. We'll do those. That makes more sense to me. So we want the color of an address. And we're going to do that like this with mod 016, I believe, to get hex. LL capital X to pad it all the way to 16. And then here, we're going to do mod S while I'm here. So that's int 64t. Could I do ULLX? I make it a uint 64t address probably, because that's just going to be node like that. Yeah, if I haven't done that before, I should be doing it now. Then color location. And that's going to be two things. Right, we're going to say mod LLD and mod LLD. That'll be long of node location offset and count length. There we go. So color for the tree name, color for the node location, color for the two source location things. Then we probably just want to go reset the color or set it to the tree color again. So I'll do one more mod S. I'll reset, which should give us ANSI color reset. Come on. Yeah, that's fine. Okay. And at the very end of all of that, I have lots of other things I do there. We just want to append a new line. So that's where I do the reset. So let's do the same thing here. Print context output throw the new line at the end so we can print extra stuff depending on the type in the middle here. And then also, final thing I want to do is HBK vector syntax node pointer children is null, just so we can vector free, and it's not called syntax node, it's HBK syntax. We can vector free the children later. And really, we can just say if children not equal to null, then free the children and print children, print context children, like that. So then when we do implement printing children, it'll be right there ready for us. So we append the line, get ready to print the children. Do extra printing plus calc children. And that, C is very fun. I love C, and I would highly recommend you learn it. It's not something that I recommend you use for all your projects like I do. I'm a little bit crazy. I don't do a whole lot of different projects, so I don't change language very often. And, like, honestly, we probably should have done this version of a compiler in something that wasn't C if I'm going to write a book about it, but we are where we are. It's only been a few days. I could stop, change it, but I don't think the book is going to care about it being in C as much as it's going to care about being just a good reference for compiler devs. And if you're writing a compiler, you should probably learn to understand what I'm saying in C anyway. Yeah, go learn C. C's fun. So, if nothing went wrong, which it very likely did, because, so indents here is null. Here's the problem. This is the first thing I'm thinking is going to be a problem, because right here, it's going to print the null string right there. So, print contents, indents this, or the empty string. How about that? Then we can string append to it, which will, let me just double check here that I'm doing message length +1 to make sure it stays null terminated. Yes. Okay. So then back in here, after we print, or after we parse print, we want to print the tree to an output string. So HBK string debug output, print to the output with state use color as our color flag. Then we can fprintf standard error mod s new line debug output, which should be null terminated, and string destroy, which doesn't exist, but for some reason is in, okay, it's not anymore. HBK vector free debug output. And then we should, if nothing went wrong, see the 3 nodes here. And I went through that kind of quick, so I'm kind of expecting it to be wrong. Let's see what happens. That's the code button. I didn't want that, actually. I wanted that. Lots and lots of bads. So, passing argument of HBK string append format of incompatible pointer type. Because it probably does need to actually be by reference. So, this one, it's taking in HBK string pointer. For output, that's fine. For indents, it needs to be a reference. Okay. Print context output, passing argument 1 to format. Yep, that needs to be this. Then string append format here, that needs to be this. And control reaches end of non-void function. Way the hell at the top. Is that because this doesn't return null like I wanted it to? Perfect. Okay, so the gray color, kind of ugly, but it's the biggest number. It's printing the wrong thing because I think it's LL. Oh, yeah, the U part doesn't matter, that's why. I'm doing ULLX, but since it's X, it doesn't care about signedness, so LL does make sense, and I can just cast like size T or something. And there we go. So this one doesn't actually show up, it shows up as null. For the y though, because I didn't include case syntax invalid. Invalid. All right. Valid. There we go. So we have an integer literal at 0 with 1 length, an invalid thing at 2 with 3, that's our foo. String literal at 6 with 7 length, which is hello with 2 quotes, 1 on either side, so that's 5 plus 2. And our bool, which is true, which is 4 characters at position 14. And these are the locations in memory of those nodes. So we've started printing a syntax tree here, which is kind of cool. And our magenta turned into purple, so that's good. That's good as well. We like that. So we've done a bit. We've done that much of a bit. Git add begin parsing Hibiku source and printing it for debug purposes. And that is now available for you all to see. Okay. So when we start parsing nodes that have children, which should be relatively soon, depending on how long I let the string go on, we've already gone for an hour and a half, so maybe I don't do a long one today. But soon, when we start parsing, we're going to want to be able to print the children of things, and we'll come back here to implement that. And really all we've got to do is put a little switch right here where I put the to-do, and anything that has children, we append to this vector, and they'll get printed. Simple as that. We may want to include, actually, yeah, while we're here, before we call it good, switch on node kind. We'll even kind of start that, because we can say case invalid. We then want to append format of print context output the space mod s mod s. So we could call it a name, but I'm probably just going to do straight up color bright red or something. Color bright red. And the other s is going to be dot star s, I think, because I'm going to want to grab the location information for the token raw and put it in here. So that's going to be int of node location offset plus the text offset, basically, which is gonna kind of look awkward in an expression. Maybe I pull this out and I say HBK source text. Doesn't exist, that's right. So string view source text is HBK get source text. In print context doesn't have a state. So it should have a state, and then node location off source ID. So in order to get that state, the tree doesn't have a state either. So HBK state, and then use color, we're going to copy in from the state. So then dot state, hibiku.c, state, that, then print to string here, HBK state, use color like that, parse. Okay. State use color doesn't fucking exist, actually, so we still want bool use color. Actually, we just want the state for API purposes, so then print context state needs to exist. HBK state, then offset, we want to be relative to source text data, and then, well, no, actually, wait, hold on. This is not the part we want to int. We want that there, and then the length is the part we want to int. So without doing anything else fancy, this should give us the, right there, string value of, we've already done bright red. Bright red is orange in this one, so I just did regular red. That would give us this. Interesting. So there we go. This is the invalid token. That's part of the invalid. And we just stick it there. So we could do the same thing up here for integer literals and stuff. We could say case integer literal. Literally just yoink, well, let's yoink only the first half. Up to like here. Mod s break. So what we want is mod s mod LLD for node literal integer value, and the mod s is color of literal. Right, and that would give us 1. So that's like actually orange. I wish these things were standardized. I might just have to convert this shit to not these colors. Cool, so there's our integer literal. We can do the same thing with the string literal by saying, we're going to want to change this later, so I'll add it to the to-do. Print the escaped version of the literal. So this will be string literal. String literal. String value is going to be SV expanded. And the color is still going to be literal, but it's going to be dot star s. And that'll give us hello, unescaped with no quotes. So just to be clear, it's a string, even though it should be obvious. Do that, and then boom, hello. And then bool literal can be all the fun same stuff, except we'll just mod s bool. And instead of anything here, it will be, and actually just keep that and say bool value true false. And there's true. And we can do that for whatever data we want anywhere in our syntax tree. And these addresses are kind of annoying, so we might want to not prefix them 016 like I did, leading digits up to 16. We could just say the address looks like that, and that's probably much easier to read. But, yeah. So that just changed those couple of files. Git AC, add additional, add token values to existing debug printing. Cool. Anybody have any questions or things they want to look at the current parsing that we've implemented, or the debug printing, or anything at all? If not, we're going to keep plugging away probably. Oh, but I need to stretch apparently, or do something because my elbow is not happy. Oh, God, I'm tired too. That's not good. I should probably like turn those off. So in parse, couple of things we could do. One of them is add identifiers. It would be cool to have a visual mind map. What do you mean by that? We'd like where we're going with the parser as a whole, the compiler, the language, the Hibiku, like a spec, for example. Because we could go try to spec it out. I don't know, like, EBNF very well. Oh, I said, like, 4 things, sorry. For, like, the compiler part, or for the language itself that we're compiling. So if I did, like, for the parser, Okay. We can probably do that by quickly trying to build an eBNF for it. So if I said like eBNF, does that exist? No. Does BNF exist? No. And it's not prompting me for anything. If I come over here and search for BNF, or yeah, so I could add BNF and eBNF highlighting, and that would make it easier for me because I don't remember how to do this stuff half the time. What is the BNF? Okay, so this should be BNF. Okay. We could have like I don't know, what the hell do I want to do here? What's like a primary? Because I always call this thing primary. And let me go open up an eBNF reference so I know how to actually write this. Because this will also handle like the lexical cases, not just the can't join like the stream. Sorry, it's an hour and a half later. Oops. I'll copy this over. I forget I have a browser for this, so I can still... Oh, are we writing grammar now? Well, it'll probably help explain where we're going with the parser, and probably just be useful to have anyway, especially if I'm going to write into the book. I can point people here and say, here's the grammar of the language, make it a fucking thing, I don't know. So... Oh, you can do spaces? That's fun. Right, so if we wanted to come over here, integers are plus or minus natural numbers, with natural numbers are digits excluding 0 plus any digit. I mean, yeah, fuck it. Let's start building by copy pastaing. Digit excluding number. Integer is, did we say 0 or that? Steal. I mean, I'll do whatever. It's this, ta-da. So, like, I don't understand. We probably don't need this at all. We're not doing, like, 0 prefixed anything at the moment. I guess we could be, but we probably don't need to be that. Let's just bonk, 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 bonk. There's a digit, and a natural number, they said, was any number of digits. But I could just also say that, right? So I could just do this plus digit plus digit. That's why they did the excluding 0, so they didn't have a 0 at the start of a number. But we don't care. So if that makes sense, then that makes sense, I guess. So then, like, formatting-wise for these things, do we want to have, like, this? Is that how you format goddamn BNF? I don't know. Integer. I mean, for something like this, it's short enough that I don't care. But... So, like, I've never really thought about road mapping a parser, which is why I jumped straight to a BNF grammar. But... Oh, yeah, I mean, if we don't have to do that. Number. Perfect. I just don't know where to start, dude. I've never written these things. You know me. I just kind of put it in my head, and the parser is the description. So let's move it off to the side, maybe. So let's map it to what we've got here. We've got a primary. A primary so far is an integer, number, or an integer. It might help. Sure. Let me You have, hey, it's a quiz. I remember that. How are you doing? We are taking a short break to see if I know how to write EBNF grammar so I can try to better explain the roadmap for the parser. You haven't missed much in the parser. So far, we've just got it parsing a couple of little leaf terminal primary expressions and giving us some information about them. And we're going to work on something a bit more complicated once we explain what the hell that means. So let's see. Where's your grammar? Final grammar. Do we have to put them in little... Oh, there's a grammar BNF somewhere too. There it is. Don't look at that, but it's called final. There's so many things. Look at all the things. So many things. I mean, it probably doesn't hurt. So we can just do expression literal. Haha, that's what we just did. We did literals. Fuck it. Step 1, steal from charade. Step 2, do it again. So your expression literals, you used all the capital things to say things that you didn't describe, I assume. Or like keywords, that makes sense. Yep, literals and terminals, that makes sense. So we want integers, strings. We don't have arrays, so we're going to include probably true or false with ours, but unless you have like an expr true or an expr false. So like basically what I'm looking at is integer literal or string literal or true or false, for example. Yeah, I didn't see them. So there you go, which is really just capital true, probably, and capital false, if we don't care that much. So there's our expression literal. We have a couple of places we could go. We could do, like, for example, decal local. We could do local declarations, which are going to probably be the primary way that we declare things. I don't know how we want to do non-local declarations. True and false are like one of the first things I add to any language. What we did right here, aside from like the fact that I skipped declarations because I'm a masochist when I do parsers normally, this is the first thing I do in every parser I write, is true, false, the rest of the literals, and I call it good. We are not the same, I guess. Oh, and we want colon colon equals to make charade happy. So decal local, for example, we could go the way of, because what I want to do with Hibiku is not have a bunch of complicated parser nightmares to try to teach people. I can allude to the fact that you might want to have different parser states or keep track of where your parser is and make it rewindable for more complicated things, but as much as possible I want to avoid the complications in the book to not make it too long. So we're going to do things like everything that matters is going to either have a keyword preceding it or be obvious by a context kind of deal. So we could say, hey, decal local is local plus an identifier. So identifier, local identifier equals. Now, do we want commas between things? Is that something? Not really, no. Expert colon colon, for example, no. So local identifier, and then this could be optional, which I assume is parens. Break or continue is, no, it's not. This is optional. Optional is squares. That makes more sense because parens are just grouping, A or B. So this would be equals and some expression. And then regardless, a semicolon. Right, so that would be how we do local declarations, and those would be relatively easy to parse. We should probably define an expression. An expression could be a lot of things. Do you have like a parent expression type here that says what these can be, or do you just assume that anything that prefixed with expression is an expression? Oh, you do right there. That answers my question. So, for example, expert colon colon equals expert literal, and we can build that out later. So you formatted it as or everywhere, which makes sense. So we'll keep this on the same line, and if we need to, we'll add more things to it. So how do you fucking BNF your binary expressions? Do you give a shit about binaries in any particular binary? X per binary up. You know what? That makes sense. We'll use that as our second one here. X per binary. There we go. So now we can say that. So we could go the declaration route. That's one thing we can do. Yeah, I didn't figure I'd do precedence either. So if we're doing local, we probably also want to have the equivalent for global declarations. But if they're at global scope, maybe we don't call it global already. Because what I'm thinking here is we could have like local foo equals 10, and that is only visible in this file. And we can also have function bar local baz, local to whatever scope they're in and all the child scopes. The BNF file does absolutely nothing. It is just purely for us to visualize what we're talking about. It is a standard way to describe these kinds of languages, just different textual things. You can read about the BNF format on the Wikidepedias. I clicked on the wrong browser. I have two browsers. So we were just referencing this earlier, but extended Bakashnar form, eBNF. Yeah, so it's just a reference more than anything. You can use versions of BNF and eBNF in parser generators and stuff. I don't know if it's like the same, but it's similar enough, right? So like if we went to Yak, right, I did just mention, Saraid, that I kind of want there to be a sigil, a keyword, something, so that we don't have to do like speculative look ahead or switch what we're doing. So I would like there to be some way to know it's a global or a local. So we might just say, I could do colon equals to put things in global scope. Because like the problem is at the top level here, if I just said a equals 10, that could be an assignment or a declaration, and I want to have type information. So I think we want to go the route of like a colon equals. So if we have a type, yeah, BNF is before eBNF because extended was better. So yeah, Yak uses BNF at least to an extent. So you'll define your grammar here and it'll generate you a parser, and we're not going to use that. And I'll briefly describe why we're not going to use that in the book. I'm not very well talk about how not good, bad. Anyway, so, right, like I could go the colon equals route here. For local variables, I like just this, and the like type is optional, but you don't have to like local colon equals. But I guess the local keyword is not necessary if we just use colon equals as the declarator. And then if it's at top level, it's global. If it's in a function, it's local. But then you can't have a distinction between exported and imported, public, global, private, global, whatever. Yeah, conflicts, error messages, weird stuff. Not great. So yeah, I don't mind local. I'm very used to it being a Lua programmer myself. And I'm still not sure how light or heavy on types we're gonna get or like exporting things and importing modules. I don't know how deep I want to go into building a compiler. I want to get from front to back for the whole thing, but I don't know what kind of features we're going to support, what I want to try to compile. Are we going to go like some dynamic typing like Lua tables, or are we going to go everything has to be a struct that's pre-declared? I don't know. Who's messaging me? I'm getting messages. My cake is now even more dry. I keep forgetting about my cake, guys. So basically, I don't have a super good idea at the moment. I kind of want to see what walls I hit and not do them if they're too hard for the book, basically. But having a plan is probably not a bad idea. So variable declarations like this, let us say foo pika colon. Easy. But they don't give us export and import. So I could do everything local by default and export foo colon equals something, right? Like that would work. So this would just be baz colon equals 10. Right. Hmm. Because then if I go for this kind of declaration, I feel weird doing a function keyword as well. If we're doing static names, then yeah, local makes more sense, because you don't want to reintroduce something to the global scope from within here. So local to the file, and sorry, like static for global. So the question, I guess, becomes if this is a global, like if we're going to allow executing the main body as a function. If this gets parsed as an implicit function with other functions inside of it, technically, then do we want like static function, export function? Do we want like exporting from main to be how you make something global? Question mark. Basically, do I want to do this is a main function, it gets called, versus like a mod, it could also be the module initializer function, right? And then we have ways to say this is not technically part of the initializer function. Well, what do you mean by how do you declare a scoped static class? If you mean like static class as in like the C# static class where it's not instantiatable, we're just not going to do that because that's a stupid construct that I hate. So yeah, if we're doing the C# Java thing, we're just going to consider that a lost cause and not even talk about it, honestly. The whole point of static classes is that you can't have free functions, and when you've just got a free function, you don't need a static class anymore. They're static classes in Java and C# and anything else that has a similar concept is just because they were afraid to add functions that weren't associated with a class. And so they drank their own Kool-Aid so hard and refused to change their minds. And now we're here. Classes are just namespaces. Just should have just been a namespace. Yeah, static classes make absolutely no sense if you have free functions. They don't really make sense in the first place, but they're kind of necessary in C# and Java and other people who have done the same thing. Because you do need free functions. Not everything can be associated with a heap allocated object. You don't want that all the time. That's why the singleton pattern exists, and we fucking hate the singleton pattern too. But singleton is way more useful, at least, than normally a local class also has access to this pointer, the parent class. Yeah, that's right. But yeah, so Java makes it even more complicated, but you know. Probably, yeah. I don't know exactly how they work. I know I used to use them, and now that I don't have access to them, I don't know why I cared to use them in the first place. Um, anyway, so I really like keyword languages, like using the keyword function bar. So I would love to use the same kind of thing to declare things. Like var is whatever. So aesthetically, my brain wants to say local should require a keyword to declare something. So we can say, hey, we hit the local keyword, parse a local, right? But and bleh. I'd rather just use var if we're not going to include mutability, which we might. We might include mutability. I don't know. Um, bleh. Auto implies the type goes here, but the type goes here. Right. So, yeah, we have things to think about. Yeah, have a good day. See you next time. Yeah. This colon equals fancy shenanigans is like the current trend in programming languages, so we might just want to copy it to make it approachable. But then I lose my fancy bar function. Like, it's not symmetric anymore, right? So then I'm tempted to go fucking bar like that and go a full jai moment here, right? Which is fine. It's just not what I want. My image of Hibiku had more keywords, and keywords are pretty. I love keywords. Symbol soup is just symbol soup. Um, hmm, I may have to think about this more then. Hmm. Yeah, I still think I prefer this to be function bar. Which I guess is technically not. Technically it doesn't. It's fine, because its function declares it takes arguments, it returns this, so that's the type, right? So we could just, I mean, we could do that. That might not have been done before. Gets ambiguous, though, so I don't like that either. So, function. I don't know, let works. I like local. Local's easy to type. So is let, but local's easy to type, so I don't really mind. And then we can omit the colon. Most people just leave the colon in there and are like, yeah, look, it's a colon equals operator. It's one of them old things. But also we could just be like, yo, if you have the local keyword, you don't need it. And if you're declaring a global, right, then you don't get the same luxury though, which kind of sucks. So I probably want to say like static foo or export foo or something, right? And then an export foo could have the same type inference benefit without the colon as well. Honestly, I like the look of this better. If we're going to stick with function, I want to have some signifier before declarations, just for the symmetry. And I don't want to use let. I like local and export. Because I want to also teach type inference, so I want the parser to be easy, but also still provide us the ability to omit some tokens for type inference purposes. So even though this is here to like, look, guys, we can type inference, requiring the colon feels redundant when you've got a keyword. So if I allow a keyword, I want the token to be omittable as well. But I can only make the token omittable if the keyword exists, right? So for now, I'm thinking this is what we're going to do. So let's start with parsing declarations to just get that out of the way. Let's do an export foo and a local bar. And that can be 34 and 35, our favorite two numbers. And we can try to parse that. So in here, instead of global, we'll call it export, decl export, except yeah, we'll call it decl global actually, because we're also going to have things like function, which could optionally have an export behind it, but the function syntax is going to be the same otherwise. So export identifier, this, and then, right, so we got a lot of things to do here. And then a function body could be some function body, could be a couple of different things. It could be a this plus some number of statements. I'd make the one rule and write export or local or something like that. Decl scope, export or local. Yeah, probably. Like, and then we'd want the type inference to also exist in here as an optional. Yeah. So that would be colon is optional, and probably also after the colon is optional. No, I feel like in this case the colon should only be required if you want the type information. So then this would be type, right? So then we'd have type equals primitive. So then we can just say type primitive equals, if the type primitive could be int, or I think we said float, or a string, whatever we decide string is going to be, or a bool. Characters are going to be integers probably. So like there's our current primitive types, whatever the heck. So then a variable could be either an exported or a local variable. Semantically, only locals will be allowed inside of functions, but that's a semantic thing, not a syntactic thing. Decal function could include export or local, and it would be optional instead of required because it's going to be function, right? And then in here, we'd want comma-separated list of arguments, which I'll figure out how to do later. And then optionally, the same thing that we've got here. And then a function body. And a function body could be either this or a semicolon. And then this would be like a block, a statement block or something, statement compound, STMT compound. So it could be an expression compound. We can just do the expression language thing. But right now, we'll call it statement compound. This will be any number of statements. Yeah. So then it's this, or we could do the ye old easy return thing, that of any expression and a semicolon, or that, and those are our three function body options. And then in here, statement could also just be a this. Then anywhere that we could use a statement should probably also be a declaration. So we can grab a fucking decal and say if we're looking for a statement, we allow a declaration. So and then a declaration is specifically a decal function or a decal variable. That, make this a touch bigger since things are getting so wide. Right. And then a binary up, we haven't defined yet. That's going to be something like plus, minus, star, divide for now. That needs to be or, not just any of them. And we can include equals, not equals pretty early. Yes, and greater. We also did all the assignment variants. We had modulo in there, so modulo. Then we should probably go ahead and get these all formatted on the right spot. I'll fill that out later. Doesn't matter right now. So like that's where we're going. So in the case of function, It doesn't need to have local. It could just optionally be exported. So then with this construction here, we will need to be able to peek. So we can come over here to and include our peek. So we've got parser token and HBK token parser peek token HBK. I'll just call it peek. HBK parser P in offset. And in this case, we're not relying on anything, so we're going to do the same thing here and say int64t peek index is going to be p current index plus offset. And then we can just return all of the same stuff with peek instead. So, I mean, like that. So then we could actually make current token in terms of parser peek, p0. That's our current token. So now that we have peek, let's just introduce a peek at, which is just going to take the int offset. So then this is going to say peek at offset kind is equal to whatever. So now we can say, hey, if we're at export, is the next thing function or local? Then we know, hey, if it's at export and it's function, well, I mean, okay, so if it's at export and it's an identifier, then it's definitely a thing if it's an export and it's function. Anyway, so we can look at those two. Statements are declaration or compound things. We're looking specifically for a declaration. It's only one of these two things. Compound statements are here. Primitive types are there. Binary expressions. We'll get to binary expression parsing pretty soon. Yeah, I think the easier thing to start parsing is statements and declarations here. We can go ahead and implement the decl function, for example, or a decl variable we said, so we can get these two parsing. Oh. My poor cake, it's all dry. Very sad. Dry and sad, sad and dry. So let's see, who asked about where we're going? Emilio? Yeah, this is... Hello, Zed. I don't know how much longer I'll be going, honestly. I'm getting a little tired. So I'm going to try go long enough to get variables parsing. Variable declarations, that is. So you're just in time for that. We're about to start. I was just saying to somebody who asked for it earlier, Emilio, asking for like a roadmap of what we're doing with the parser. So I sidetracked myself. We're starting to write a BNF grammar. And this BNF grammar is basically our roadmap. We'll add to this and we'll implement whatever the hell's in here. So if our goal is to implement variable declarations, then we need to have optionally types. I might skip out on types for now, but we'll see what I feel like when we get there. Expressions and these kinds of things, and all of that needs to be parsable from a declaration probably. So we've got a couple of functions to implement. So let's see. I might want to have a... Yeah, because like this is technically incorrect, I think. I mean, it's not, but it's fine. Do I have anywhere that I care about it being a primary? Probably not. A primary is going to encompass literals. It's going to, like, expression lookup or something. Lookup expression is an identifier. Okay. So primary covers these top two cases for now. Expression we'll just call primary so that we can parse whatever the hell we want. later. So I'm going to rename this to expression primary to try to keep it kind of in line with our EBNF. So that means we'll want declarations up here, parsing a decal. If we're parsing decals, then we want decal function and decal variable. Yeah, I don't like regex all that much, so BNF was of course my first option. And Sarade had an example for source, his language, that we kind of stole from. So, yep. Let's see. BNF is just fancy regex anyway, so they're like the same thing. So with a decal and a decal variable, we're also going to want to parse a type. Hell yeah, everybody's copying each other. Let's go. After decal, we want parse statement. Statement will call decal or whatever else it needs. Compound is probably worth having a thing for separately. Okay, so to get started, let's start parsing expressions instead of primaries. Return parse primary. Easy. So then, wherever the heck we're parsing, right below here, parse expression primary, we're gonna go just parse an expression, which will parse a primary for us. That's step one done. Cool. Next, we want to start doing declarations. So that will be right above expression here for now. So we're going to do a variable. We're going to skip out on function for now. We're going to do declaration. To parse a declaration that is a variable, we probably have to have known at some point what these two things are. Is it exported or is it local? So we'll probably just take in HBK token, like the declaring token, decal token, like that, and add that to our blah, 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 declaring token here. And what we'll probably want for functions is just a bool is exported or something. Or like export token, which could be not existent, it could be just empty. We might want those. So let's go back into parse variable. Oh. Did I close it? I guess I closed it. Didn't show up. Okay, so to parse a declaration, we're going to go ahead and HBK assert p not equal to null, invalid parser pointer, and then HBK assert decal token dot kind is equal to token local or export, which we're going to go add to our keywords. Hibiku variable must start with either local or export. And HBK assert parser at p token identifier. And that means this function expects to be at the variable name. So then HBK token, variable token is parser token and parser advance. So now we are somewhere. We are somewhere else. Not quite over the rainbow yet. Unreachable. While I go add a new token keyword. So local export format. Okay. We also have const, which we haven't added to anything, but that's fine. Maybe we just don't do constants. Yeah, because I could just say const like that. And then now we've got lists of modifiers of things that we could modify. So I guess instead of this, we would then call it like a decal modifier. Or an attribute, for example. So then we could say attrib. Which could just be const. That could be one of the things. So then this would be and is it like, do we have like squirrely brackets for multiple things? This? Yeah, we do. Okay, that makes sense. So attribs, for example, many attrib, 0 or more attrib. So then we have an optional attribs. And we'll get to actually parsing the attributes later. I don't care that much, but putting them in the BNF so I don't forget, probably worth doing. I'll put attributes at the top there. So, and then we could also have attributes that are like, I don't know, this style, bar, some shit. Oh, right, because it's going to be 0 or more. Yeah. It's optionally 0 or more, but it could be 0. And 0 or more. Okay, so then we have export, which automatically gets added to our lexer. Easy peasy. Then something in here it doesn't like. Too few arguments to call. Oh. Okay. Then unreachable, return null, just so we can at least attempt to do something, because we're not calling it yet. Where'd my YouTube go? There it is. Okay. This. Cool. So I'm just totally in the wrong thing. So this should still work. And we have all of the errors for the parser. That's fine. There's all of our invalid nodes. That's fine. We got our 34 and we got our 35. For reference, that's those two tokens. Okay, so parsing expressions just fine. Now, let's change it from parsing expressions to parsing declarations. Because at the top level, we don't want statements yet. We haven't decided if there's going to be a module initializer function, which there might be. There very well might be. We haven't decided, and since we haven't decided, I'm not going to bother with it yet. So in parsing a declaration, we'll get to how we switch on this later. First, let's just implement our local here, or our export. It has already been determined if this is an export or a local. We have the name, so then we're on to the part where it's optionally typed and optionally got an expression, and then eventually it'll require a semicolon. Since we're going to be doing semicolons a lot, this is hello, Ouijaler. Have I tried to pronounce your name before? What? Did I call you Ouija board last time? That's ringing a bell. How are you? So then we want to like consume semi or error probably. Void hbk expect parser expect semi is probably good. Hbk parser p hbk yeah, but we already know what it's going to be. We're going to say if not parser consume p semicolon. Then that's probably going to give us a warning or an error. Add diagnostic, hbk diagnostic create. which returns a diagnostic and also adds it, right? That's what I forgot about last time. But yeah, pushes it. Okay. So HBK diagnostic create. We're discarding it, that's fine. P state. Then the diagnostic kind is diag error. The location is current location, so parser token p location type, and the format is expected semicolon. Okay. There we go. So now we can expect semicolons and get a consistent error message. So at the very end, HBK expect semi. Cool. So what I want to do here is we know we're at a variable declaration, so we don't have to keep a bunch of temporaries. We can just allocate our syntax node. Syntax local node. No, it's not a local node, it's a var node. Is create syntax creates in the parser. That's really where we care about it. That's probably going to have to change. I probably do want an internal one that creates it within the state somewhere. Or within the tree, probably. We don't know about the tree at the moment. I put it in the parser because that's where we had the data, and I didn't want to give access to the tree. But I think we want it to be in the tree, because if we have to create any nodes in Sema later, semantic analysis needs to be able to create some things. And it's not going to have access to this. So after I type this line, we're going to go change that and then come back. This will be syntax var variable. It'll probably also be decal variable to match our EVNF. So that's HBK syntax decal variable. We'll add that in a second. The location will be the identifier. So we can actually just yoink that, put it back up here, and then it's at variable token location. Then var node dot variable, for example, dot name could just be the token name. Name equals variable token string value, right? So we got a couple of things to do here. Step 1, make this small again. Step 2, go back into parse, add struct decal variable, maybe. I called it just regular ass variable, but decal variable matches our EBNF. It needs a string view name. It's going to need a syntax initial value. I can remember how to fucking type init it. There we go. It'll also want type if it exists, and that's our whole decal variable basically. It will want to know if it's exported or local. So really, we could just say bool exported, and if it's not, it's local. So bool is exported. Boom. Right. Then we need to come up to the node here. So we've got a couple of things to do. We need a decal function, a decal variable, vartable. A decal can go to an STMT compound, and this can go to just a straight up expression primary. We already have the expressions there. Type will come probably after expressions. So we could just do type primitive, type integer, for example. Well, we'll get those in place. And that's probably all we need to get parsing. Then, another then, in parse.h here, we have HBK parse. We have syntax tree to store and create. I'm going to come into here where we have syntax create. Pull this declaration out into HBK parse, right under syntax tree, and it's going to take in a syntax tree instead. Right? So it's going to make it in the tree. So then back over here, tree. And we don't need to know about P, we just need to know about tree. Like that. Pool is tree pool. Looks like this is still syntax tree. Bam. Then we have to go back up to the top. Don't have that anymore. Then, everywhere that we do syntax create needs to take in the tree. So all I really want to do is take this, copy, I want to include the comma, copy, new, do the thing, tree, bonk. So finally, syntax tree, that's the tree that we're constructing. So all the way in the parser, tree is tree, tree is tree. Easy. Then var node, decal variable name. Now that tree is tree and all, so we could actually just go ahead and test on, well, I mean, we're missing the actual decal part. So instead of whatever the hell I've got going here, let's just say, I don't know, go Baz. We'll put it at the end, see what happens. So Baz should parse if we hit something in here. So this needs to return var node. We'll worry about the initializer in a second, basically, is what I'm saying. So switch on parser token P. Kind of. Default, then we're just going to hit the something similar to what we did here. For now, we're going to say expected a declaration, but got whatever this token is. And for shits and giggles, we'll also pull the token out. It's like before. Token, HBK token, token, parser token. So then, case token export. Or if it's export, it could be a function. We're not doing a function yet. The other option is token local. Then, so export could be an identifier or a function. So let's say advanced. We already have the token, so that's fine. If parser at function, we might want to keep the function keyword or the function token, but if it's at for now, if it's at token function, then we're just going to HBK assert and say not implemented. Not function, parsing not implemented, but we are starting to check for it. So then next, we want to say if not HBK parser at P token identifier, then we probably want to return an invalid token with the export modifier here. So something similar to this. Keep the to-do in there so I can keep following it around. Expected and identifier to name this variable. Whatever. So then syntax invalid could consume the current thing, but it probably shouldn't. It should probably just use this token, right? So then I don't actually need to know what I got this. Well, I'll leave it like that for now. That makes enough sense that it's whatever. So if we are here, then we can return parse decal variable. With p, the decal token is token. We haven't consumed the identifier yet, and we're not at a function. Parse decal. So then local will do the same check, but without the function. And it needs to go past it. So past it, and this is instead of exported, it's local. Okay. So that's good. Decal variable. So then our parser is hitting decal. If I save that and run it, how many errors do we receive? Duplicate member tree. In parser? I already did that? Oh, the tree's at the bottom. Did I assign it twice too? I did. Wow. Then enumeration not handled in switch. Because I have exhaustive switches. It's only a warning though, and we are seeing decal variable, so that's a good sign. 3 decal variables. It's going to fail on the first 2, which is why we have 3 invalids after it, I guess. Equals 34 and semicolon. So foo, it liked foo, but it didn't find the semicolon. That's why. So decal variable for export foo, and the next thing it should say is expected a semicolon. Beautiful. Then we have, yeah, the next 3 are expected these. Then we get another decal variable, which is local bar, but it hits the equal again, doesn't find the semicolon, so it finds these 3. But then it hits local baz with no initializer, and it does have a semicolon, so it doesn't error, and we get decal variable. So for what we have implemented, that's correct, which is good. So we probably want to go handle exhaustive stuff on line 316. So that's here for syntax print. Actually, I'm fine with that, because we want to probably handle this anyway. Remember to handle it. So it's currently just printing decal variable and nothing else. We should probably give it the name of the variable. So syntax decal variable. We don't need the source text, but we are going to print color name, I believe we called it. Color name. And that is just going to be a regular, no, it is going to be .s. So it's going to be sv expand of node decal variable name. If we do that, we've declared foobar and baz. Ta-da! And then, while I'm here in decal variable, if, and only if, node decal variable dot initial value is not equal to null, then node vector push children this. So now when we add a variable declaration, it's going to test our parsing here as well. These warnings do still want to handle, but they're not like necessary. So I think I will just say default break. I was going to leave them there, but there are some I'm just not going to implement, and I don't want to have a bunch of empty cases for now. So let's go try to parse a default value. HBK parse .c. We were already kind of there. Cool. So parse decal variable. Before we hit the semicolon, we want to say if parser consume, which will check if it exists, and if it does, eat it, and then tell us if it ate it. P equal, if we hit an equal sign. Then we want to var node decal variable initial value is parse expression. And that's easy. Boom. There we go. Decal variable gives us an integer literal 34. Decal variable for 35 for foo and bar. And decal variable baz. We have parsed 3 different decal variables, variable declarations. Git, so that's those files. Git add Hibiku BNF. Git commit message. Add simple BNF file for reference. Then git begin parsing simple declarations. Those two are now synced up for everybody who wants it. That's how easy it was for us to parse a variable declaration. The way that I'm trying to design the parser here, without really thinking about it because I'm so used to it, already kind of mimics how the BNF looks. We were going to write very similar code whether we wrote this BNF or not. We just kind of settled on something and got here a little bit better because of the BNF. But I can say decl variable, which is our function name here, right? I'm just prefixing it with all of our C-isms because there's no overloading, so we're keeping a prefix on everything. So parse decl variable is going to give us a decl variable. Problem being, we need to kind of know some prerequisite knowledge. So this prerequisite knowledge here is being passed into the function. But everything afterwards, the identifier onward, we're just parsing as if it's real. We expect there to be an identifier token when we get here. Boom. Optionally, we're skipping the type for now. Optionally, we expect an equals followed by an expression. So, hey, if there's an equals, parse an expression. And if there's not, well, we need a semicolon regardless. So there it is. So basically, we're just writing the BNF grammar as declarative, imperative, almost declarative C code. And that's kind of what we want out of the parser. We just want to be able to declare what we want. We'll get error messages if they're not there. We'll do our best to recover from those, but there we go. Very simple, very simple. We could probably add simple types in the same way here. So we can then also say if we hit a colon, so let's go into hello Hibiku and let's make foo not have a value, but it'll be of type int. Foo int bar is 35 and baz has nothing. So to get that, what we want is if we consume a colon, then our type is HBK parse type. Easy as. We do have to go implement parse type, but hey, that'll go right above expression. Ooh. Okay, so just like we've done everything else, I'm probably going to go steal from parse declaration, honestly. And we'll kill most of this code, but we want most of its error handling. So we'll get rid of these two cases. We still want this error handling. We're going to error and say expected a type, but got a thing. And there's our invalid thing. So we could even just do this, and it'll give us an error probably. Just how we want it, right? Oh, it didn't. The colon didn't work. I don't think we're parsing a colon in the lexer, rather. If we go to lex.c, I don't think we're lexing colon. We're not. I didn't think we'd need it, and then we needed it. So back in parse. Okay, decl variable foo has an error expected a type but got int. So it's got no children, even though it doesn't have children because we wanted to print a type if it had one separately. But otherwise it has no children. So that's fine. We don't have a way to print type information yet. So we should probably add that to our stuff to stuff. Let's get rid of everything that we're not using here so that we can actually see what the hell's going on. We've called this parse.h, but we should probably end up calling it syntax.h because we're going to include things that aren't parse related right about now. So HBK syntax. We're going to change the name, fix the compiler errors, which are probably just going to be in internal. No, in Hibiku. Hibiku is relying on parse, which no longer exists. Syntax. Because now I want to add things like we've already done printing, debug print to string here. So let's also include void HBK syntax type print to string. And that needs the state, the syntax node, the out string, and the use color. That's going to be type. And this we can implement very similarly. I'll put it down here. We can even use it. We're going to use it in the debug printing here. So do our ensure the out string is there. Assert that state. We didn't even assert that state is there. Assert that the type does not equal to null. Invalid syntax node pointer. And probably because parse doesn't exist, it's syntax now. There we go. So now we just want to print things. So switch on type kind. We're going to do a couple of things. Case type integer. We don't have type. We do have type integer. I think that's the only one we're going to have right now. So type integer. And if we say case HBK syntax invalid, we're just going to print invalid. So append format to our out string mod s int, and that mod s is going to be color of like keyword probably, which we don't have yet, and keywords color keyword here probably not going to be magenta, could be the bright magenta. Bright magenta. Well, let's see what that looks like. When we get down here, this is int, this is going to be invalid, and this one's just going to be red. Break. So if we hit integer, we print integer. So the reason we want that is because now when we see decal variable, we have this, and we can say if node decal variable dot type not equal to null, then we can HBK type print. We'll get this. So we want print context state. We want the type node. Right. We want the output string, which is print context output. And we want print context use color. But before we do that, we want to grab color reset for a space and a colon and a space again. And we don't need the name for anything. And then if we run this, we get foo invalid, because we haven't actually parsed the keyword int yet, but we know what its type is. And color reset, kind of expected to reset the color, I'm not gonna lie, but it's still blue. White? You don't really want it to be white. What the heck? It's blue. What the heck? Why is it blue? If I put reset here, what does that do? It resets it there. Oh, you know why? Because I'm fucking stupid, that's why. There we go. Now it's white. So now we just need to parse the actual type. Parse type. That's here. Base token int. That's our integer type. We just do this and this, and it's syntax type integer. We don't actually need to associate anything with it right now. And that should give us type int. Boom. Add type parsing to variable declarations and change some file. Boom. So now we have these three things parsing. And that's not bad. That's a decent start to the parser. We've got parsing and debug printing for some not difficult things, but technically not trivial. We had to put a lot of stuff into that. I don't think I'm going to go much farther today. I'm starting to get a little tired and sniffly. So, thank you for stopping by. Hope you enjoyed. It was probably a bit more esoteric this time if you're not familiar with parsers. I just don't know what to explain along the way, and if nobody's going to ask questions, then I'm going to keep going. So, yeah, thanks for watching. Join the Discord if you haven't already, if you want to. We talk about a lot of things, but I'll be talking about Hibiku, I'll be talking about my other programming language, I'll be talking about the book I'm trying to write about it. It's starting to look pretty on the website, but I don't really have text in it yet. No, yet. You can go show off whatever the hell you want. Get notified when I go live. Anything you fucking want. The source code is available in the description as well if you want to take a look. I'm not going to be accepting pull requests for probably a long time. But hey, you can fork it, star it, do whatever you want. Keep up. And I'm going to go probably take a nap or read a book. Probably read a book. Bye, everyone.